Hello guys. My name is Yusuf, and today we will solve the homework one from the computer organization lesson. So basically, homework one says that we need to calculate the number of numbers from m to n, and when we do that, we are not allowed to use the conditional brands. So let's start by doing. So we need to first assign R0, R1, and R2. So in the instruction, it's already written that R0 should be uh, n value, R1 n value, and R2 is the sum for the m values, let's say. So let's first assign, let's say R0 is 1, for example. R2, R1 is let's calculate until the 5 for now. Move R2, let's say make it 0, because when we are calculating, we need to add R1, R0 to R2, R2, so 0 plus 1, then 0 plus 1 to 2, 3, 4, 5. It will cancel like that. So for now, it's great. Oh, okay, let's create a loop and we will make some stuff here. Let's see, add R0, R2, R2, R0, and increase R0 for one value. Yes, R0. This will basically add R0 to R2 and then increase R0 by 1 and doing some process and we'll control like that. So let's understand first. We need to compare R0 with R1 to find if R0 reads to R1 or not. Then do some process. Okay, how will we do that? Yes, compare function we will use. What it basically do? Let me first slide. What it basically do? It subtract R0 from R1, and if the result is negative, it means that R0 didn't reach to R1, so we need to then go back to loop and do process until R0 reach R1 and R2 reach the expected value. So okay, sorry, my computer crashed. Okay, so what do we do? Let me read the instructor first. Okay. Yeah. So in the instructor say that R4 and about R5. R4 should be computed offset, and R5 should be actual address. Let's assign them. First, let's assign R3. I'm gonna explain what's that. So R3, no R3 forward. What does this do? R3 just let's each instructions take the 4 byte in the memory. So here R3 works as a converter, like it's instructed to the number byte. We will gonna use this, and then let's move R4 4 byte. Yeah, why we will I will explain. In the loop part, uh, we will use that for jumping back to the loop again and again and again. So I'm gonna show that. how does this work? So in the now we need to understand that for for step as a human we can understand that okay from 1 to 4 it's 4 step, but computer doesn't understand like that. We need to convert it to bytes. So in assembly it understands 4 step as a uh, 16 16 yes bytes. So how we will do that? We just move R4 by R4 by R3. So this will help us to reach to move through the fourth step. I'm gonna show why do we also need a fourth step. So here also guys we will use this here. So what do we do according to the instructor? We need to move R5 by the current addressing, let's say, of program counter. So what we are in the program. So, and then to go back to find the value of star, we need to write something subtract r I'm sorry sub r5 r5 r4. So this will just basically uh, goes to find the value of star. Here is 16 byte. I mean for movement. It's here one movement. So we need second movement and we third movement and loop start is here is fourth movement where in the assembly we just call it 16 byte back. So what now? So we compare it and now we need to finish. We need to end no SVG. Okay, let's think about it now. If we need to, if the number reads to the expected value, I mean R0 reads to the same value R1, we need to finish the process. So here, compare value, compare if the result is positive, then we need to compare one process. If positive, CPM then goes and exit and end the program. So how does it work? Should be like that. Yes. Then I guess we are done. Let me compile it. Oh great. Successful compiled. Yeah, we assigned R0 as up to R1, then R15, R20, R3, yeah, 4, 4, yes, time it increase. Yeah, let's see if the result is right. 5, yes, 15, it's right. Okay, let me first just 1, 2, 3, 4, 5. It will be 10, 15. Okay. Indeed, now let me explain it. What it actually does. Let's compile first. Yeah. Here first in first step we assign R0 to 1, R0 as 1, then R1 5. This is the sequence between R2 0 and R3 as I explained for its movement calculated as a 4 byte in the assembly. So we need to first assign R3 for 4. Bits will help us to correctly use the loop in the future. So let's see. Program count. But see, you see, 10 and it will be 14 and it will increase 4 by 4 by 4 by in the hexadecimal. Yes. 4. Let's see what it will be. R5. Yes. Correct. Great. Okay, actually, that's all about my video. So thank you for watching. I enjoyed by doing this. I learned new things. Okay, thank you. Have a great day.